Hello. We're going to do some quick notes on inequalities. So you'll see up here at the top, inequalities. The essential question is, how do you use inequality symbols to make a math expression true? So you're taking notes. Oops, I don't want a highlighter, I want a pen. Okay, well, I don't want that at all. Okay. So make sure that you have Cornell Notes set up. Today's date is the 9th, but what is time anymore? Okay, so to get started, we have two statements here. So we have one and two, yeah? All right, so 5 plus 3 equals 10 minus 2. This is a true statement. True, because 5 plus 3 is 8, 10 minus 2 is also 8. All right, so here we're going for equality, right? So equal sign. So number 2, 5 plus 3, we already know that's 8, but 7 minus 4 is 3. So this is a false statement because they're not the same value. So value goes here. All right, so for number 2, we need a different thing to make this true. So we need an inequality symbol. Inequality symbol. And so that's what we're talking about here. So we have all these different symbols, excuse me. And so it depends on which way they're facing. You'll see the verbal expression here in an example. So let's do maybe just one or two, and then you can do the rest. So for less than, let's say 4 is less than 6. So this is true. So we want to write true statements in the example. And then let's look at the last one. So not equal to, so we just saw that in our example 2. So 8 is not equal to 3. Yeah? So then you come up with those other examples. Okay. So for this next part, we're going to do a verbal expression. So verbal means words. Looks like okay. All right. So number 1, 6 is greater than or, so it has that line underneath it. So I'm looking at this one. Or equal to 3 times 2. So here I get this conjunction. I get this joining word or. So I have greater than or equal to. For the second one, we just have a strict inequality. So here I'm just going to write the number. 12 is less than 20. So you'll notice that this one's shorter. And for this example, I'm just up here at the top symbol. And so I don't have that other part about equality. I just have an inequality. Okay. Please also notice that we read these left to right, just like we do most things. All right. So here you get to be creative. Possible values n that make it true. So n is a number. I want to say that n is a number. And there are so many possibilities, so many values that are possible, infinite. Yeah? Okay, so let's, for number 1, 2, 3. So for number 1, n is greater than 8. So a number greater than 8, probably you're thinking 9, 10, 20, 400, right? And so on. You know what's missing from this list though is 8. So here I'm going to say n cannot be 8. It's not allowed. It's not in the solution set. All right, so for number 2, we have that little line underneath our inequality. So here I'm looking up above, less than or equal to, so I'm here. All right, so n is less than or equal to 15. So maybe you're thinking a number less than 15 is 14. You could also say like 14.5. You can say 10, you can say 0, you can say a lot of things. Here's the thing though, 15 is included, right? Like n is allowed to be 15 because of that equal bar underneath the inequality symbol. Pretty cool. All right, for number 3, we have a strict inequality again. So here I'm up at this one again, less than, and I did do a greater than for this example. Okay, so the first thing I'm going to notice is that n is less than 14 plus 7, which is a sum. So over here, I'm going to do 14 plus 7. I think it's 21. Yep, okay. So n is less than 21. So n could be 20, 10, 0, so on, yeah? Here's the thing, just like number 1, n is not allowed to be 21. So be careful because the sum here will sort of play tricks on you. Well, I mean, not really, but kind of. All right, so for our last couple parts here, there's some vocab. So absolute value is the distance a number is from 0 on a number line. So remember our number lines like this, yeah. And additive inverse. So we've done this a bit in class. So if you've forgotten, that's okay. I personally am going to post some math shorts that go with these 2 ideas. Okay, absolute value. Example. So here we used bars. So I'm going to do absolute value of -5 and absolute value of 5. So what's nice about this is that the absolute value of both of these is just 5. Yep, pretty cool. Additive inverse works the same way, but there's no bars. So it's just a number's opposite. So for example, if we have -2, the opposite would be +2. Just like this is a 0 pair in like pre-algebra. Okay, so 2 examples with absolute value. So absolute value, same absolute value. So for example, we can have 10 and -10. We can have 1.5 and -1.5. Yeah? All right, so for an example of additive inverse, we can have, I don't know, it doesn't matter, 7 and -7. And we can have like -100 and +100. So they're just opposites. Okay, cool. So right here it says summary. And I want y'all to summarize this in your own words. So I'm gonna write that. So in your, oh dear, own words. Okay, cool. So I hope this was helpful. Save it for a rainy day and know that learning is a journey and we will get there. All right, bye guys.